Today is May 9th, 2022. It is a Monday, and again, I'm working on another problem where I have to find the area or the proportion above a certain point. I'm going to be doing this with the normal distribution, so with just normal CDF, and I'll show you how to do that with TI-84, TI-83, and with Python. And then I'll also do it the AP stat way, the way that College Board wants you to do it, with z-scores, like showing how you get the z-scores, and then using the standard normal distribution instead. But if we read the problem, it says, a set of chemistry exam scores are normally distributed with a mean of 70 points and a standard deviation of 4 points. So Cam got a score of 65 points on the exam. What proportion of exam scores are higher than Cam's scores? Than Cam's score. So to give you an idea of what this looks like, which we'll graph it in a second, a normally distributed graph is basically a symmetrical graph. It's kind of like an upside down parabola. The ends never touch the x-axis, and the mean is always at the middle of 70. And basically, all the exam scores in this chemistry class averaged out to be 70, and each exam score deviates approximately, not approximately, they deviate 4 points. That is the standard deviation. And so the first objective here is to visualize this to give you an idea of what we're working with, what we're trying to find, and then the second part of this is to solve for the proportion of exam scores that are higher than Cam's score. So to visualize this, to make a graph, basically is what we're doing. We're going to get our x values and y values, and to do this we need to import some libraries. So I'm going to first import NumPy as NP, and I'll tell you in a second what these libraries do. Okay, so the first library, well, first of all, what is a library? It's basically a place where you have pre-written functions available for you to use, for you to call and use as you please. They're just functions that are written for you already, and you just have to call them and you can use them. Okay, so NumPy we're going to use to get our x values. NumPy really deals with numbers. SciPy deals with statistics, and stats specifically deals with statistics, and we're going to use this to get our y values. And then we're going to use Matplotlib to actually visualize our graph, so to make our actual graph. So I'm going to start first with getting our x values. So I'm going to use the linspace function that was already written for us from NumPy, and note that I used NP because I imported NumPy as NP. Instead of having to write NumPy.linspace or NumPy whatever, I do NP. It's a shorthand. Okay, so linspace is a function that takes in 3 parameters. So the first 2 parameters, you can think of them as an interval. So in your math class, if you remember, your teacher would ask you to find the domain of your function, and your domain would be an interval where it has an x point that it starts with, a start point, and then an end point that it ends with in your x-axis. And so you would say, okay, well, the graph starts from -1 on the x-axis to, let's say, 2. And ends at 2 on the x-axis. So that would be your domain, -1 to 2. And so that's the same thing we're doing here. We're getting our x values and we're just telling Python, hey, this is where I want my graph to start, this is where I want my graph to end. And the third parameter is how many values you want in between. So I'm going to think according to the mean. If the mean is 70, I'm going to think, okay, well, I know a normally distributed graph is symmetrical. The mean is in the middle, so I kind of want things to be symmetrical, so maybe I'll go with like 55 and 85. So I'll start at 55, end at 85, and I'll have like 1,000 values in between. And if I run that, you're going to see that it's going to produce or output 1,000 values in between, and it's going to start with 55 though. And then if you scroll all the way down, it's going to end at 85, just like we said. And so this is our x, these are going to be our x values. And we're just going to set that to a variable called x values. Okay, and then our y values, we're going to get by using our stats library. We're going to use a norm function, our method, and we're going to use the PDF method. So we're basically saying find the probability density function, or the probability density of all of our x values. And right, so PDF stands for probability density function. So we're finding the probability density of all of our x values, and we have to take into account our mean, which in Python is loc. Well, in this case, for this function, our mean is loc. So that's going to be 70, and our standard deviation, which is 4, which is scale. And if you're confused between what's, like if you feel like you're going to forget, just know scale starts with S, right? So standard deviation must be scale because it starts with S. They will start with S, and then whatever's left is just your mean. Okay, so those are your Y values. Now here's where the fun part comes. We're going to use the matplotlib function, which we imported as PLT. So plt dot, and we're going to use the plot function from matplotlib. And we're just going to plot our X values and our Y values. And if we run that, we should get a normally distributed graph. And that's what it looks like. And real quick, I'm just going to add a title. I'm going to call this normal distribution with, I'm just going to say mu for mean of 70 and a standard deviation of 4. I should give it a title. And we're going to say, we're going to give it an X label. I'm going to say, what was it? Chemistry exam scores. I'm going to say chem exam scores. And then PLT Y label is going to be the density. Okay, so this is basically what we're trying to find. So let me save this image. I'm going to give it today's date. I'm going to save it here. Oops, pictures. Maybe pictures. Nope. Desktop, actually, yeah, pictures. Okay. No, really? I didn't do that. Maybe I just, oh, I did. Oh, it was the problem that I saved that as that. Okay, so now I'm going to go over here to my whiteboard. And I'm going to import this image. If I can find it. I don't even know where I saved it. I don't remember. Was it in pictures? Is it this one? I think it is. Okay. So let me lock that and let me connect my tablet. Okay, so all right. So now we can get to the actual math stuff of this. So again, the problem says what proportion of exam scores are higher than that of CAM score. So what is CAM score? It says that CAM got a 65 on the exam. So a 65 is right about here. Why is it not letting me? Okay. A 65 is right about here, right? So this is CAM score. And they want to know what proportion of exam scores are higher than that of SAMs. So basically, this is the proportion, this is the area under the curve that they want to calculate. This is the area under the curve that they want to calculate. So this is the area under the curve that they want to calculate. That is the proportion. Also, it's the same thing, area and proportion that we're trying to find. Proportion? Did I spell that wrong? Yes, I did. What the heck? Proportion that we're trying to find. And how can we do this? We can do this in multiple ways. So with a normal distribution, using your TI-84, you can simply do this by using a calculator, very simple function in your calculator. So you get this function by going to second vars 2. It's called your normal CDF function. So it should be number 2 in that menu there. And once you click on that, you're going to get a few options. You're going to get lower, upper, mu, sigma, and they're going to have like a paste section. Okay, so I'm going to walk you through TI-83. So in your TI-83, you do the same thing. You go to second, vars 2, and the only difference is that it's just going to give you normal CDF, and it's going to look like that, and you're just going to have to know what to put in there. And usually, let me actually make it a little smaller. It's going to be normal CDF And you're going to have to put, we call it lower bound, upper bound, mu, and sigma. Let me move this line over here. What is wrong with this thing? Okay, mu and sigma. Okay. So, in Python we'll actually do later. I'm just going to show you how to do these on the calculator first. So, okay, so where are we? So, in your lower is the same thing as your lower bound. So, you think of it as your first, think of it as an interval, I guess. Yeah, it's an interval. You're describing what area you want to find, like what's the interval of the area you want to find. So our lower bound in this case would be 65 because we're starting with 65, and then we're trying to find the area, all of this, which is to the right of 65, which is, what the proportion of exam scores that are higher than CAM scores are basically all of these. And notice that this graph never ends and it never touches the x-axis, and so it goes to infinity. And because there's no infinity symbol in our calculator, we use 1e99 to represent really big numbers. So let me just do that. So our lower would be 65 and our upper would be 1e99. And then our mu was given to us at 70 and our sigma was 4. And then for a TI-83, you would just say normal CDF, your lower bound 65, 1e99, 70, and then you would do 4, and then you press enter, and here in your TI-84 you hover over it and you hover over paste, it should turn black, and then press enter, and then you should get a certain value. So from here you should get a certain value, and that is going to be the proportion, right? That's going to be the proportion of exam scores that are higher than CAM scores. That's going to be your answer. And I'm actually going to do that real quick. Just give me 1 second. Let me get my calculator. Okay, so I'm going to use a TI-83. So I'm going to do second vars 2. I'm going to put in 65, comma, 1e99. The e is second comma, which is above the 7. 1e99, comma, 70, comma, 4, close parenthesis, enter, and you should get 0.8943. Well, it's actually 5, so 4. Okay, 89.44. That is the proportion, that is this pink area over here. That's the proportion of exam scores that are higher than that of CAMs, 89.8944. So that's how we do it that way. Then how do we do it with z-scores? Well, z-scores, the formula for z-score is x minus mu divided by standard deviation. So here's the thing. You first have to get this x is whatever point they want you to find the area above or below it in any case, but in this case it's 65 because it's the point that they want you to find the area above it. So it's going to be 65, and the mu, again, we know is 70, and then the standard deviation we know is, what was it, 4. So this is your z. So if you put that in your calculator, write 65 minus 70, divide that by 4, you get negative 1.25. Okay, so here is the thing. I'm not sure right now if I keep the negative or not. I'll get back to you on that, right? After we do it, we'll see if it's the same answer. Bless you. So basically, this is our z-score. So now instead of doing normal CDF, we're going to do we're going to do normal CDF, except that it's not going to have the mean and standard deviation of this normal distribution, because z-score is known to be a standardized score which we use in a standard normal distribution, and a standard normal distribution has a mean of 0 and a standard deviation of 1. Bless you. So, oh my god, are you okay? Bless you. Are you okay?
I've been sneezing all day.
I haven't heard you sneeze all day until now.
No, it was in school the whole day.
Do you want medicine?
Mm-hmm.
Okay, let me ask mommy. Hold on. Okay, I gotta pause this video now. Okay, so where were we? So a standard normal distribution has a mean of 0 and a standard deviation of 1. So it looks like this. Let me actually plot it for you. Let me just copy these things over here. And just change it to 0 and standard deviation of 1. And just change it from -2 to 2. That's what a standard normal distribution looks like. It starts at 0 right in the middle. Not it starts at 0, but the mean is 0, and each point deviates by 1 standard deviation. So basically what we're doing is we're converting each point to a z-score that we can use to basically do the same thing we did with the normal CDF, but with a standard normal, which is literally the same thing. Okay, hold on, let me just show you. So for the TI-84, so for where is my pen? I'm such a mess today. Okay, so again, your z-score is equal to x minus mu over that, and we said it was -1.25. Okay, well, essentially this is actually supposed to be here. So z-score is equal to -1.25, and then using our TI-84, it's the same thing. We go to second, vars 2, and then for our lower, we have our upper, we have our mu, and we have our sigma. Our mu, well, first of all, our lower, actually, hold on. Lower, upper, -1.25. Yeah, it's the same thing. So you start at -1.25, but I don't think it's, I don't know if it's negative. I'll check on that real quick for you. So, well, for now, we'll say -1.25. So, and then 1E99, because it's the same thing, it's the same area. The only thing we change is just the point. And then instead, mu is 0, and the standard deviation is 1. And then you hover over paste, it turns black, click enter, and it should give you a certain answer, which we'll get to in a second. So in a TI-84, you do second, vars 2, you do normal CDF, you plug in your value there, 1E99, and then you plug in 0, 1, click enter, and I'll do that in my TI-83. So I'll do second, vars 2, -1.25. We'll see if we get the right answer with the negative, because I'm pretty sure I'm supposed to take the negative out, or if I'm wrong, I think I'm confusing that with T star. 0.89, what is it, 0.8944, yeah. Negative 1.25. Yeah, no, okay, we got the right thing. So when you enter for both of them, you get 0.8944. So yeah, they basically just want you to do this with z-scores, right? Instead of, oh my god, instead of using just the like calculator speak is what they call it in College Board. They don't like to see that on AP test. They like to see your z-scores, that you understand basically what you're doing. Why is it like this? So yeah, z is equal to x, the point, minus mu, divided by standard deviation, and here it was 65 minus 70 over 4. Okay, now, that's what it is. So yeah, so the reason I was like saying I'm not sure if it's negative, it's because I think in like inferences in statistics, I think we don't take we take the absolute value of our z star, which is something completely different. I was just confusing those two things, but yeah, we just take, that's your z-score, just plug it in to replace whatever point, whatever x value you're trying to find the area above or below of, and that will work for you. That's what College Board wants to see, that z-score what do you call it? Z-score conversion. Okay, and then now I'll finally show you how to do this with Python. So with Python, we'll start with the normal distribution. With Python, let me actually just show you. So let me go over here. If I do another code snippet. Okay, so over here. So to find the proportion, right, that's higher than the proportion of exam scores in chemistry that are higher than CAM scores, we're going to do the following. So we're going to do stats.norm. Again, we're going to use a norm function, and instead of PDF, we're going to do CDF because we're trying to find the cumulative density function. Well, we're not trying to find the cumulative, that is a function. We're trying to find the cumulative density of of a certain point. So it takes in 3 parameters basically instead of 4, which is the difference between using your calculator and Python. CDF only takes 3 parameters because it only calculates the area below a point. So here's the thing. You might be like, okay, well, if it calculates the area below a point, then it's always going to calculate the area below a point. And so how am I supposed to find the area above a point? Well, you just do 1 minus whatever you get for CDF, because obviously if when you're using CDF, no matter what you put in, if you put in 65, if you put in 65, you're going to always get the area over here. And if you just do 1 minus this area, you're gonna get this pink area over here, right? Because you're just doing the opposite, 1 minus, right? So let me delete all of that. Okay, so, but I'll show you that in a second. So basically, you'll start with CDF and you put in your x, so it takes in 3 parameters. Your point, which is 65, your x, and then it takes your mean, which is 70, and your scale, which is 4. And then if you run that and you round it by 4 decimal places, and you see that we don't get the right answer. We actually get this area right here. This is with Python, by the way, don't get confused. We actually get this area right here. If we add this area and this area, we actually get 1, which is, right, 100%. But how do we fix this? Again, we just do 1 minus that. Run that and we should get 89.44. See? So yeah, it's basically just taking the opposite of that. Another way to do this is if you do norm.cdf, SF is the same thing as doing 1 minus ADF, so instead of having to do 1 minus blah blah blah, SF already does that for you. So you put in the same things, your point, which is 65, your loc, which is your mean, scale, which is your standard deviation, and just, you round your answer, so apply the round function 4 decimal places, and you should get the same answer. I feel like this is easier. So that's how you do it with a normal distribution. Now, if you're going to use z-scores, you can definitely write a function that takes in your x value, your mean, and your standard deviation and gives you the z-score for you. You know what? Let's actually do that. I wasn't planning on this, but I guess we could do it. I'm going to do z-score, and I'm going to do x, mu, and standard deviation as parameters, and I'm going to say, okay, well, my z is going to be equal to x minus mu, in parentheses, divided by my standard deviation, and my function is going to return z. So if I call my function z-score and I put in my mean, which is, what happened? Oh my god. It froze. What is going on? It deleted my code. Let me just fix that real quick. Okay, so again, let's do def z-score takes in my x, my mu, my standard deviation, and then what are we doing? Okay, z, which is my z-score, is equal to minus mu. Mu is mean, by the way, and STD stands for standard deviation, and then we're just going to return z. This is supposed to be entered. And then if I call my function z-score and I put in my values, so my x was 65, mean was 74, like mu, and the standard deviation was 4, it's not going to give me anything yet. Well, it is, because, oh, well, I guess, interesting. Anyway, yeah, it is going to give me anything. It's going to give me our z-score. See, that's perfect. Okay, so now what do? Well, I'm going to set this equal to, maybe I should just do my z-score. Should I set it equal to a variable? I'm going to call it z-score. Okay, and then I go over here, right, and I do the same thing. So stats norm.cdf, and instead of putting my point, which was 65, I just put my z-score, which I assigned it to a variable z-score, just a different name so that they don't get confused. And I put my mean, which is loc of 0, because we're using a standard normal distribution, and a scale of 1, and it should give me, well, and then we have to do 1 minus that, and also round that. Not again. Don't tell me it's going to freeze again. And it froze. And now we have to wait. Okay, round that and we get our answer. So this is what happens when we used our z-scores. So, or we could just do this by hand and plug in our z-score here of negative 1.25 and it'll still work. But I just decided to do it with Python. But yeah, so to kind of recap of what we just did, let me just eraser. What is going on? It's literally not working. Alright, so to recap what we just did with Python in a normal distribution without using z-scores, it's kind of similar to the TI-83 where we have what is going on? Like, why can't I write with this? Okay. So it's kind of similar to the TI-83 where instead of, well, normal CDF, oh my god, this thing is going crazy. It's not letting me write or anything. Okay, so let me just, what if I just get out of here and then reload, go home and then go back. And now we wait 5 hours. I need cold water. Okay, so alright, so for this one we did stats dot norm dot cdf, and we could only put 3 parameters, so we could only put our x, our mu, and our sigma. Now remember, our x in this case is 65, but our x is basically the point, right? It's the point we're trying to find the area above or below under, and it just happens that in this case we're trying to find the area above 65, so 65 is our x. And then you would know what 65 is because in your z-score conversion you would have to, know what x is. But yeah, so stats.norm.cdf, right? You would put in those values for your normal distribution, so you would just put in 65. So what did we say? So it was 65, 74, and then when we entered that, it gave us 0.1056, which is the area of this, because CDF in Python calculates area below x always. So in order to get the area above x, you would have to do 1 minus 0.1056, which was equal to 0.8944. Or option 2 was to, let me write it up here. So let me erase that. So option 2 was to use stats dot norm dot sf, which is the same thing as 1 minus CDF, or 1 minus stats dot norm dot CDF. Right, it's the same thing as that. Also note that stats.norm CDF is the Python equivalent to the normal CDF function in your calculator, except that it doesn't have, lower bound and upper bound. It only has one parameter for your value, which is just x. But it's basically the same thing, except that you have to know that in Python, there's only one parameter, again, x, and it only calculates the area below that point. So you could use this instead, and then just put in your values 65, 70, and 4, and it should give you 0.8944. Okay? And then when you have z-scores, you first actually have to find your z-score, because it's not, I think there is a function that finds your z-score for you. I just haven't looked into it. I usually like to make my own functions because that's how I learn. But you would use, you would find z-score. That's really bad handwriting. You would find your z-score. You can do this by hand, or you can do this with a function, which we did. So let me just take a screenshot of that function. Hopefully I can paste it. Nope, I guess not. I'm gonna have to save it. Really? I could have pasted it? Could have told me earlier. I don't think I see it anywhere. Oh, there we go. Whoops. Okay, so let me just take this. Right there, just put that in there. And then let me do myself a favor and just erase all of that. And just write it over here. So what was it? 65 minus 70 over standard deviation, which was 4, negative 1.25. Okay, so find z-score, and then the second step was to just do stats dot norm dot CDF, and then you would put in your z-score, your mu, and your sigma, which is always 0 and 1 for a standard normal distribution, right? So in this case, it would have been negative 1.25, or just your z-score, 0 and 1, right? And then you would have had to do, that would have given you 0.1056, and then you would have had to do 1 minus 0.1056, and that would give you your 0.8944, or you could have done option 2, which was to use stats.norm.sf and just put in your what did you put in? Your x, right, which is your z-score, right? Negative 1.25 It's the same thing, 0 and 1, and then it should just give you a negative 0.8944. I can barely see that. 0 and 1. And then how in the world do I write a 4 like that? Like, what? Oh my god, I cannot. Okay. Okay, yeah, I think this pretty much sums it all up. Did I miss anything? Let me see. Did I have to do 1 minus z-score? Yep. I got everything, I think. But yeah, I'm really happy that I figured this out because I spent a lot of time researching how to do these things as I was in my stats class. I just had no idea how to do it, but I'm really happy that I learned how to do it and I could finally, say that, I know this, like, and I could, like, be confident that I could do something, like this. And it took me a while, so I worked really hard for this, so I'm really proud. And all thanks to the glory of God. I literally remember, like, if you go back, you can see my frustration. Like, I have, like, a whole, these logs are literally diaries, basically, of, like, everything that I've been through to, like, everything that I researched, every video that I saw, like, everything I read to get to this point, and all the prayers, literally. I had to, like, I don't know, I was to a point, I had to pray. I was like, God, like, I need you to help me find this function, because I needed it to, like, for my test, because I didn't have a TI-84, and in TI-83, you can't do certain things, and so I was like, God, help me. I needed, like, to figure out a way how to do certain things with Python, but that's for, like, inferences. I keep talking about inferences, and this is not even inferences, but yeah, but I also had trouble with this too. I was really confused by the fact, why, like, how am I supposed to find the probability above a point if normal CDF only takes in 1 point? I can't put, like, a lower bound or an upper bound. I was so confused about that, but then I realized normal CDF only calculates the probability below a point, so then I would just have to know what I'm looking for and use the function and then decide if I'm staying with the answer, which is, not the probability, excuse me if I said probability, the proportion below a point, then I'll stick with CDF, what the function gave me. But if I'm looking for the proportion or area above a certain point, then I'll do 1 minus that, or I'll just use normal SF, so stats.norm.sf, which is the same as 1 minus CDF, 1 minus stats.norm.cdf. So yeah, I think that's great. I think we're good. I think I covered everything that I could. But yeah. Yep. Okay. Should I do like a... No. So I guess, like, if you were to get anything out of this, I would do like a little post-it note. Let me do like a... Ew, I don't like that color. So let me make it a little bigger. So if you were to get anything out of this, is... like, you have to lock everything. I'm kidding. Okay, so you would do basically, so we have normal... Why does it write so ugly? Let me just zoom in. Okay, so you would write, so it would be normal CDF is the same as stats. Well, not really the same, but it's the same idea. Except that normal CDF only takes in your lower bound, upper bound, mu and sigma, and then stats norm.cdf takes in your x, mu, and sigma, and then just know that CDF in Python, right, is below, or area below a point. And then, so CDF in Python is area below a point, and then 1 minus CDF is area above point, and then 1 minus CDF is the same as the SF function, which is stats dot norm dot SF, and you put your lower bound. Oh, not lower bound, upper bound. You just put your x, your mu, and your sigma, and you should just get, 1 minus CDF is the same thing. And yeah, I think that sums everything up, except like the z-scores, but that's like, yeah, you don't need to know Python for z-scores. If you're going to use z-scores, I'm assuming you're only going to use them for College Board, because why would you use z-scores if, I wouldn't know. I still need to practice with, or like dive deep into z-scores and their usefulness. I know they're good for comparing things, but anyway, whatever. This is it for today. I'm gonna go to sleep. Have a great life. Bye.